Well, good afternoon. I want to welcome everybody to what is the first in a series of WIRES-sponsored transmission technology webinars. WIRES is planning to hold a webinar once a month for at least the next several months, featuring a new or advanced technology aspect relating to transmission. And this month, kicking it off for us, we're pleased to have Surveying and Mapping LLC, or SAM, present on, I'll make sure I get this right now, terrestrial close range photogrammetry, or measuring my photos. And we're pleased to have some of SAM's top experts here to present today. Before I go ahead and introduce them, I just would like to mention, for those of you who are watching the webinar, we are going to have an opportunity for folks to ask questions. So as we go through the presentation, if you've got a question, go ahead and put it in through the question feature, which is on the right-hand side of your screen. If you submit that, we'll be happy to put that question up to the panel of experts for them to respond to or answer your question once they get through the presentation. I really encourage folks to provide any questions they have, because we're interested in trying to get everybody educated on this technology and what its uses are for, and how it's used and what the advantages are of it. So, so without any further delay, I'm going to go ahead and introduce our lineup here today. We've got Brian Fitzpatrick, who's the spearhead for UAS programming for SAM. We have Tom Moore, who's the Southeast Market Business Development Director on as well, and Josh Dillier, who's the Manager of Business Development for SAM. So Josh, I'm going to go ahead and turn it over to you, and we're ready to go ahead with the presentation. And as I said, remember, present those questions for us, because they're anxious to answer them after we get through. Josh, go ahead.
Perfect. Thanks, Larry. Yeah, so again, I'm Josh Dillier with SAM. My background is transmission substation engineering. I'm a PE, electrical engineering PE, so very involved in NERC compliance and facility ratings for many, many years. So in my role at SAM, it's been a pleasure to help develop this solution for utilities across the U.S. And Larry is right that the name of the title was a mouthful, but really what it essentially is a conductor measurement, remote conductor measurement to support FAC-008 compliance for utilities. So before we dive in and talk about the agenda, I wanted to do a quick safety minute. Here at SAM, we always kick off our meetings and presentations with safety. Quick safety minute. So today we'll touch on substation and transmission line safety, a few safety points. The bullet points here are mostly on public facing, like information about, don't approach electrified substation or energized substations. But to drive home the point with FAC-008, and when our crew or any field crew is inside a substation, it's important to adhere to minimum approach distances to energized equipment. So for our personnel, if we're bringing equipment inside a substation and it has any type of height to it, we'll perform a minimum approach distance calculation. We'll look at the voltage levels and refer to the NESC for what those minimum approach distances are, and make sure we're operating in a safe way. So always important to look at before entering a substation. So today we're going to be talking about FAC-008, the NERC compliance standard for facility ratings. It's not a new standard. It's probably one of the older standards that have been out there for many years. It's becoming more and more challenging to verify equipment inside older substations, especially because it's harder to take outages on the transmission grid these days, with changing generation dispatch and renewables coming online at a pretty high clip. It's hard to take outages in order to physically make contact with a jumper or a bus section or a bolted connector to verify that piece of equipment and say, hey, this is the facility. This piece of equipment is rated at a certain amperage, and it is or is not the most limiting series element. So you have to find ways to measure conductors and bus sections fast. And the best way, one of the better ways to do it is if you can measure without de-energizing the system, that bus section. So we'll go over the background of NERC FAC-008. We'll talk about facility ratings, just a quick review of what a facility rating is. We'll talk about the FAC-008 reporting, because from a NERC compliance perspective, that's key, is how you document your substations or your transmission lines facility rating, so that if you were to go through a NERC audit, you would have the proper documentation to show compliance. We'll wrap up the presentation moving into FERC 881, because what we're seeing, a lot of the data and information that we collect in the field for FAC-008 will relate to FERC 881, and that's ambient adjusted temperature ratings for your facilities, for transmission lines. I think most utilities see that as the next hurdle from a compliance perspective, is dynamically rating your transmission facilities on an hourly basis. So we'll have a quick discussion on that. And then, as Larry mentioned at the top of the call, we'll have 15-20 minutes to do some Q&A and answer any questions that you have. Quick overview for SAM. We're a geospatial company. We collect data out in the field and process the data and give it to engineering firms or utilities to do design work with, is essentially what we do. Been around since 1994, so about 30 years old. We're a large company, 1,500 strong across 47 offices, with many licensed surveyors and professional engineers on staff. For electric utilities, IOUs like yourselves, a lot of what we do is fixed wing assets. We own our own airplanes, so we fly transmission lines to collect LiDAR data for transmission line design. We process the data and put it into PLS CAD format so that your teams can do the engineering design to reconductor lines or build new transmission facilities. On the substation side, we do quite a bit of substation scanning to create 3D models, or in some cases BIM models, where we'll embed the models with metadata to create like a digital twin of the facility. Inside the substation, obviously, we do FAC-008 remote conductor measurement. On the distribution side, we do quite a bit of mobile mapping. So we support undergrounding programs across the U.S. where we'll map distribution facilities above ground, create a LiDAR model essentially, and then we'll do the SU, subsurface utility engineering, data collection, and create data sets that show utilities, the existing above ground facilities, and allow them to do the undergrounding design, directional boring for undergrounding distribution feeders. So that's a brief kind of overview of how we support the electric utility industry. Quick snapshot of our utility clients, several good examples here. I am the business development manager for Florida and the Carolinas, so I work quite a bit with Duke Energy and Florida Power and Light, the next era regulated utility. And several, I think a majority of these utility clients, we have performed this remote conductor measurement in support of their FAC-008 compliance efforts. So a lot of good experience across spectrum there. All right, so FAC-008, like I mentioned before, it's an older standard. It's related to facility ratings. Transmission owners and operators are required to correctly rate their transmission facility. And so typically a facility is a transmission line plus its remote end substations. You want to make sure that the rating, the amperage rating, is correct, so that if you don't inadvertently push too much current across that facility and overload the facility or a component in the facility and damage equipment and trip the line off. That's where some of the blackout situations we've had over the past couple decades have occurred, is you trip off a line due to undersized equipment, and bad things occur. The frequency, the grid frequency gets off kilter and starts tripping generation offline, and it's cascading effect. A big part of avoiding that scenario is to make sure your facilities are rated correctly. Inside a substation, the facility rating includes the major equipment, so circuit breakers, switches, your transformer, but also all the interconnecting equipment. So jumpers, bus sections, bolted connectors, all the equipment that ties the major pieces of equipment together. And typically a utility can look at their as-built drawings to identify the correct ratings for the equipment inside the substation. It's well documented. But where the gaps are on those interconnecting equipment. So the flex jumpers, are the biggest pain point for utilities. Oftentimes your as-built documentation won't tell you which conductor was used to tie your switch to your circuit breaker and your circuit breaker to the main bus section. So the traditional way, you can see the picture on the right here, is a person up in a bucket truck with all their safety gear on and putting a pair of calipers on that conductor to measure it. That works, but it's costly. It takes time to get the crew out there, to get the equipment set up, to de-energize the facility oftentimes, which we all know taking an outage on the system takes an act of Congress these days, so we want to avoid it at all costs. So Sam developed a technology to help utilities with measuring these conductors and bus sections remotely from the ground without making any contact with that equipment. So as I touched on, a facility rating is the current capabilities of a transmission line and the remote in substations. So in this example, we have a 138 kV line, 795 ACSR conductor rated at 907 amps. I think I pulled that off the Southwire conductor catalog. So when you determine the facility rating, you need to consider the rating of the transmission line and the rating of the equipment inside substation X and substation Y. So again, the circuit breakers, switches, and the jumpers. Typically, the utility wants to have the conductor, the main conductor, be the most limiting series element. You want your conductor to limit the rating of the facility so that you get maximum current flow across that transmission line and substations. Again, and then the last bullet point is what I mentioned before. If you have an underrated, let's say you have a jumper between a substation X, a jumper that ties the last switch to the bus section. If that jumper is rated at 750 amps, let's say, and the utility pushes 900 amps across that facility, the jumper gets hot and it burns up and disconnects, and that entire transmission line trips offline. Now let's say there's a generation facility connected to substation Y. That generation facility could be removed from the grid, and that's where bad things occur in terms of frequency and the potential for blackouts. So it's a very important NERC compliance standard that transmission operators need to adhere to. So I mentioned the traditional methods of collection. So at this point, I'm going to hand it off to Mr. Fitzpatrick, Brian Fitzpatrick, and he's going to go ahead and talk about the traditional methods and how Sam has developed this new method for remote conductor measurement.
Thanks, Josh. So how we got started in this, we had a client reach out to us because they wanted to avoid one of the traditional methods. It was going to take a long time and be, cost a lot of money. The method they were going to go with was climb up with calipers, take a measurement of the overall diameter, measure the diameter of each individual strand, and where they could at a dead end or something try to get a count of the outer strands, then take those 3 data points and use those 3 data points to verify the conductor type based on manufacturer's data. So they could use the manufacturer's rating, which is the first bullet point in NERC FAC-008 in the text on how to do this. The other one of the other traditional methods is visual verification. It's obviously much faster than climbing with calipers, but not as accurate, and certainly not as accurate when you're trying to do something like get the most out of your line. A lot of times when you're using visual verification, you kind of end up going with a worst case scenario, and so you lose the potential to put more energy through your system. And then the last part there, I already talked about, where the caliper method collecting the 3 data points. That'll come up in a little bit. So next slide. So the method that we developed is something that we call terrestrial close range photogrammetry. Photogrammetry being measurements from photographs. Unlike some of the 3D modeling that you may have seen with drones, this uses a single photograph, so we're not stitching together and creating a 3D model. We're taking a single photograph and doing the measurements from that. We typically take the measurements from 60 to 200 feet away, but we call it close range because in our world of surveying and mapping, photogrammetry has been used for 40 years, maybe even more, 50 years, to take measurements from a photo from the air. So we took this established technology, turned it on its side, and it for this purpose. So using this with the cameras that we have available, we can get an accuracy of plus or minus 0.03 of an inch for both the conductor and the strand diameters. Typically, like I said, we take them from 60 to 200 feet away, but we've made some in excess of 600 feet. And a single crew, really a one-person crew equipped, can do 25 to 50 measurements per day in a substation. So it's nearly as accurate as calipers. It's not, but it's and almost as fast as visual verification. So turning out to be a very good middle ground. And then each time we take a measurement, we do it in a software that records the location, and it's stored in a GIS. Next slide, I think. And Josh, if I forget something, just jump in and be like, hey, you forgot this. So there's a couple ways that we use this technology, a couple methods we use. Sometimes we are out there by ourselves with the records, with the bill of materials, and we're with the 3-line or 1-line drawings, and so we're taking the measurements and doing everything ourselves. Sometimes we're with, per the client request, we're with an engineering firm. So we developed a way to make in-field calculations. So we get asked a lot, what's the turnaround time from the time you take the photo? It's about a minute until we get an initial measurement. And so if we're working hand in hand with an engineer or engineering management firm that's out there, they can use that to immediately verify what they. So a screenshot there of the software that we use. This works for stranded conductors as well as round buses, like you see, and flat buses with the same 0.03 of an inch accuracy. So there's some engineering applications to being able to look at the thickness of a steel component down to 0.03 of an inch. And then on the right is just a screenshot of one of our initial GIS systems where we track where each of these measurements are taken, so that it helps now, you know, track these large projects where we're taking 5,000, 6,000, 7,000 measurements. And it sort of future proofs against some of the requirements of FERC Order 881 as well. So that's why we incorporate that.
Yeah, Brian mentioned the methodology, or how SAM gets involved in the FAC-008 compliance effort for utilities. My recent experience, or some clients that I've worked with here in Florida and the Carolinas, the utilities have already performed the field walkdowns of the substations of interest. They've created what they call FAC-008 worksheets, you know, spreadsheets identifying each component and its rating. There's gaps though. There'll be you know, jumpers, bus sections, maybe a wave trap that they could not verify in the field or against the as-built information. And so SAM will be hired, or we'll dispatch a crew to an area and visit several substations within a week and take those measurements. And based on the measurements, we'll identify the conductor. We don't assign the rating. We're not an engineering firm, so we're not going to take that conductor and say, hey, this conductor at this ambient temperature is rated at 1200 amps. We simply identify the conductor, or the diameter of the tubular bus, 4.5-inch Schedule 80 bus. Yeah, we'll put that information in the fact sheet, and then the utility or the engineering firm that they work with will then assign that rating. So that's how one way that we support these FAC-008 efforts for utilities.
Next slide.
Yep.
Okay, so how the process works, our managers will start with a kind of a 3-line there, and we identify the portions that we need to go out and measure in the field. We'll take our measurements, again, using a single photograph from a very high resolution camera with a really long and adjustable length lens. We'll take some other data points that have to be taken into account, like the range, all that goes into the math behind it. And then we take our measurements and we look at conductor databases from Southwire or Alcoa, client databases like their bill of materials, what's written on the 3-line, and we find the best match. And we put, you know, these are all the things that are within 0.03 of an inch and plus or minus, you know, one strand of the outer strand count that we calculate. And then we present it in a format that shows you from the top down where we measured, an location photo that shows exactly where on the conductor we measured and what it matches and what the diagram read. It can be presented in any format, in GIS or attached, you know, as an attribute to something in PLS CAD or you know, any type of modeling software. But that's the process. That's the process is, you know, identify what we're going to do, go out and take the measurements, and then look at how those measurements compare to what should be out there and what other things are out there in databases.
Yeah, that's correct. In the bottom image with the SAM logo, that's an example of one element inside a larger FAC-008 report for a substation we visited. Obviously, we redacted, you know, some of the project information and the client name, but you will oftentimes have a FAC-008 report for several substations that we visited. Each page of the FAC-008 report identifies one single element inside the substation. Typically, we'll work in bays, you know, like a 230 kV substation. There'll be equipment that needs to be identified in 4 or 5 of the bays. So, you know, we'll try to use nomenclature that's easy for the engineer that we work with to tie this report back to specific equipment inside the substation. The example we have here is actually a measure of a bus section as opposed to a jumper. But majority of what we do is measuring jumpers inside the substation that connect equipment. Brian, were you going to mention something?
Yeah, so one of the byproducts of using a photogrammetric method is that you're taking pictures, and so you have those pictures geolocated. You know, by using this method, one advantage is that you have a record that stuff was actually done, and it's verifiable, it's repeatable, it's very scientific. We keep track of all the information down to what range we were, the size of the pixels, all of that. So if there's ever a question, we can go back and look and see if our calculations were off, etc. Another advantage to doing this remotely that some of our clients tend to like is that we can and have on several occasions filled in those gaps from outside the substation. So we haven't had to make entry to the substation at all for several projects, which I know that can be a bit of a pain depending on how it's done and the qualifications that go into it. So it's sort of one more advantage to this. If you want to go to go ahead, Tom.
Hey, Brian. Yeah, this is Tom Moore. Wouldn't it be accurate to say that the other two methodologies that were discussed, the visual verification and the caliper measurements, have the same challenges in terms of that third piece? In other words, the end view. If you don't have the end view available, so that you won't know the strand count for those two methods as well. You kind of have to get there the same way for those other methods.
Yeah, whereas with the math that we designed on this and the accuracy of the measurements, we're able to come up with an outer strand count, and then that gives us a huge third data point. There's a lot of conductors, from Southwire alone that will fall within. You'll have multiple conductors that fall within 300ths of an inch in terms of diameter and strand diameter, but one has 21 outer strands and one has 24 outer strands, and obviously varying ampacities. So that's a big differentiator in that we're able to remotely calculate the outer strand.
That was the point I was trying to make.
Yeah.
Thank you.
Brian, can you spend a minute talking about the audit process? Like we for the client that we started performing the FAC-008 work for, and they went through an audit, and our documentation helped them pass that audit.
Yeah. So we did this work about 11,000 or 12,000 measurements. Now at the time, I think it was about 9,000 measurements that we had done for a client in the Northeast, and they had this as part of their published methodology, which is required under FAC-008. They went through an audit from FERC and they passed. So that was a big deal for us. We get asked that question a lot. Has any independent agency looked at this? Has NERC looked at this? Has any FERC agency looked at this? Yeah, that was October of last year. So it's been almost 11 months since that happened.
Yeah, and part of that audit process was us producing the documentation for some of the substations that we visited and performed the work, but also going through some of the details with the auditor on how the measurements are taken and how the photos are taken, how the measurements are calculated, and how the conductor is identified. And that whole process, we were supporting the IOU because obviously a NERC audit or any FERC audit or any type of compliance audit situation is it's good to have your vendors and your suppliers ready to help support that. So we were able to do that for the client.
Yeah. I guess next slide, and I'll wait for the questions and turn it back over to you, Josh.
All right, sounds good. Yeah, so we've touched on it a couple times with substation scanning. This is a good method for capturing FAC-008 measurement data in a point cloud as opposed to the PDF. Now, I say that the PDF will always be necessary from a compliance perspective. You want to have a PDF that you can drop into your compliance folder for every substation that qualifies, every bulk electric 100 kV and above substation that you have. You want your compliance documentation readily available in a PDF format. Where a point cloud, where a scanned file of your substation becomes very useful is when you need to replace a piece of equipment inside the substation to avoid derating the line. So back to the most limiting series element, if you have a switch, a disconnect switch, for example, that's underrated or rated less than your conductor, you need to have a project to replace that disconnect switch. With a scanned image with a point cloud, for instance, the people in the field collecting the FAC-008 data, they have the capability, they're all cross-trained to scan a substation. So if you collect a point cloud of the substation, you can then host that point cloud onto a GIS platform, or GIS Online, for instance, and all your groups, all your stakeholders inside the utility can have access to that point cloud and the equipment that's needed to be replaced. So procurement, engineering, construction, operations, asset management groups. It's a great place, become a platform to develop your equipment replacement project to get your facility rated correctly, to avoid derating your line. So over on the left-hand side, the folks in the field here, there's a couple examples of how we scan substations, we being SAM. The top image is your terrestrial LiDAR equipment, and it scans a certain part of a substation. You move that around the substation several times to collect your point cloud data, and you combine that point cloud data to get your final product there in the middle. The person on the left, the bottom left, is wearing a mobile LiDAR equipment that Sam has been using for a couple years now. And this allows the user to actually walk around the substation and collect point cloud data, LiDAR data on the move. And it really cuts down on the amount of time necessary to scan a substation. And so this is ideal. We see this paired with FAC-008. Sam go out and collect FAC-008 information, conductor information at part of a 230 kV substation. Okay, well, the crew goes out, does our measurements, and then we can scan while we're in the substation, scan just that section of the substation, create your point cloud. And sometimes you may want to do some modeling, like actually create a 3D model like you see at the end of this work stream. But with the point cloud technology, the technology we have now to process point clouds, you can actually geotag or embed data into the raw point cloud, which is perfect because then you can very easily upload that to your GIS platform. And again, it's just that hosting capability is a game changer for utilities, especially large utilities with multiple stakeholders that have to touch any given project to replace, to do brownfield replacement work inside a substation. So we're seeing utility clients move in this direction. Go ahead, Brian.
Josh, one other thing on this, this is a good method for incorporating the FAC-008 data, not only to know where and your most limiting component is, so you can get it up to replace that one portion, but when you decide that you need to put more through the substation and say, like, you find, my most limiting component is 795 ACSR. Well, this gives, by doing it this way, adding the conductor type and ampacity as an attribute to those lines that you see, you can filter out everything but my most limiting component and immediately know how much conductor I need to replace, how much, 1431 ACSR, I need to replace it. Do I have that in my laydown yard? You know, what's the back order on that, et cetera? Do any of our other companies have that? So there's some project and maintenance management advantages to not only knowing what it is, but how much of it is. Anyway, I wanted to throw that.
Yeah, no, you bring up a good point. In a lot of the key CAD platforms out there, such as MicroStation and Autodesk, they allow you to tie in your procurement system to it. So Maximo, for instance, you can tie your Maximo data into your online 3D models, and exactly like you said, Brian, you can select equipment and do quick inventory checks, or even automatically create bill of materials. I mean, obviously you want an engineer to review that BOM, but there's a lot of great tools built into these CAD platforms these days. Now, to get to that point, you do have to have a point cloud. You do need to hire a geospatial company to come in and do an accurate scan of your substation to get, or your transmission line structure for that matter. You need to do an accurate scan to get to that point.
One other thing, Josh, I'll throw out there on this too is it adds another tool in your tool bag for storm response and damage associated with weather events, hurricanes and large events like tornadoes and hurricanes, particularly.
That's correct. All right, we'll go and wrap up. I believe this is our last slide, and it's touching on FERC Order 881. So whereas FAC-8, the NERC standard, is aged pretty well. It's been around for a while. We all have a great understanding of what they require and how to get there. On the opposite end of that spectrum, I believe for the entire industry is FERC Order 881. And that's around ambient adjusted temperature ratings for your transmission lines. Again, this is required for all TOs and transmission operators and owners to implement by 2025. In terms of our discussion today has been mostly around substations and measuring equipment inside substations. So in terms of rating a facility, a transmission line, your substation is going to be, for the most part, a static rating. You know, your breakers, your switches, bus sections, they're not going to change based on the ambient temperature. However, you do need to identify the most limiting series element. You need to verify the facility rating as a baseline for your ambient adjusted temperature that will apply to the main conductor that ties the two substations together. The key part of this FERC 881 will be bringing in weather data from NOAA, probably. That is, NOAA links and data is what FERC has identified as the key source. So you can use Met towers and other technology, but to accurately rate your facilities based on an ambient temperature in a given area, you'll need this information hosted on a GIS platform. And measuring elements in the field and having them geospatially located is key to the success of your FERC Order 881 implementation. We see that the work that we're doing, we're supporting our utilities. The utilities do to get FAC-8 compliant is building like a foundation for FERC Order 881. And we've through our involvement in trade organizations like WIRES and in reading the NERC and FERC publications and orders, it seems like the FERC Order 881 will be implemented through FAC-8 over the next few years. So very interesting. We're keeping an eye on it and excited to see where it lands. Tom, anything to add there? I know you've been tracking that pretty closely.
No, that's correct. And I think that's the plan we're hearing from both FERC and NERC, is that instead of creating another standard for this one, they will just revise the FAC-8 standard to include requirements for the 881 order. and very similar to the level of detail that you see in 08 now. So having the two together, I think, brings some interesting aspects to how we approach this from a utility standpoint. And, you know, does it make sense to combine this into a program that addresses both the 008 and 881 requirements?
That's right.
It on that note, it can also be a way for organizations to shore up their NERC compliance, which is often an O&M project, by creating a capital project to, you know, to be in compliance with this new FERC order that's coming down. We get asked that on the business side, how do we capitalize this, because the you know, the O&M budgets are what they are.
Great observation. Absolutely an issue. And I will say one more thing real quick while I got the floor. And I suspect somebody will ask this, so maybe I can get ahead of the questions a little bit. But the NERC fines associated with FAC-008 have been pretty substantial and pretty frequent. There've been, if you just look back over the last few years, there's been a number of fines. Some of those pretty substantial. I think the biggest one I saw was $4.5 million, primarily for issues involving either the data for facility ratings being absent or being incorrect or not fully supported. So this is a big deal.
Well, actually, Tom, you kind of hit at the end there a question I was going to pursue, which was about the potential for NERC violations on FAC-008 matters. And so it's more on that data aspect or that documentation aspect where you would typically see those fines, or where is the area where they tend to get tripped up for purposes of fines?
I think if you're looking just at the FAC-8 piece of it, it's the collection of the data and the calculation of the rating and proper documentation. In some cases, the documentation didn't exist, and in the other cases it existed, but it was not of quality that NERC or the local implementing agency in our territory, it's SERC, S-E-R-C, but was not adequate. And most of these are negotiated settlements, usually over a period of time. So the fines might have started even higher and wound up coming down due to efforts by the utility to comply. I don't think anybody is out there just basically we're not going to do it. It's more not having the right program and being second guessed down the road a little bit. So I think it's really, really important that we utilities get their head around this and make sure they're providing documented data for the FAC-8, and I strongly suspect that 881 will be a similar exercise. So one of the things I think we're offering is to bundle this. Brian talked a little bit about that already, but try to bundle it all into a report that can be used for numerous things that would be related to 08.
Yep. Well, I want to remind folks they have the opportunity to submit any questions if anything occurred to them as the presentation went through. You guys did a very thorough job on a fairly somewhat technical and complicated topic. So very much appreciate that. I have a couple questions I thought I'd throw out there and give you a chance to elaborate on or address in the meantime, and see if we get some questions from some of the attendees as well. But one I wanted to ask about, because I just don't have the level of familiarity you guys do with the specific NERC standards, but does FAC-008, does it say anything specific about the methodology that's used for determining rating information? Does it talk about that at all?
No, for the most part, the onus is on the transmission owner or operator to determine the methodology by which they identify equipment. That's, I think, it's one of the things that people do appreciate about NERC for the most part is they allow utilities to implement their standard practices on their own and develop the best practice. So no, the NERC does not require a certain methodology.
Where we do see quite a few of the smaller fines is when there's an audit and the methodology is acceptable, but they found that in one or more cases the company didn't follow that methodology, didn't follow what was written, and didn't adjust their methodology when they changed to a different procedure.
Yeah, I'll add to that the standard itself does provide in Section 3 some examples of the expectation, and it talks about things that are acceptable to EEI and other technical organizations and that are defensible from good engineering practice kind of approach. So I think there are some of it you could come up with ways to do it that wouldn't be repeatable or defensible in regard to good engineering practice. I think that's probably a good way to look at it. So it doesn't say you have to use this particular method, ASTM, whatever. It basically just gives you kind of a set of boundaries that you need to be cognizant of.
And another question I wanted to ask you about, you talked somewhat about this technology in conjunction with FAC-008, and then you've also talked about it in conjunction with compliance on FERC order number 881. Can you talk a little bit about the relationship between those two, FAC-008 and order 881, and elaborate more on that a bit?
Yeah. So FERC order 881 requires transmission operators to ambient adjust their transmission line ratings based on the ambient temperature in a given area. The idea being that you can ship more power across the transmission line when it's cooler in a different area. And that relates to the sag of the transmission line. As the conductor heats up, the sag will get lower to the ground and cause issues. But you know, if the ambient temperature around the conductor is cooler, you'll have less sag. So you should be able to push more power across it. Really, what FERC order 881 is driving towards is organically creating more transmission capacity. Larry, that was a big discussion we had at the WIRES conference earlier this year in Asheville, was around transmission capacity limitations and how that's creating a bottleneck for renewable interconnects and interconnecting new generation to the grid. To establish a baseline for your ambient temperature rating, you have to define the facility rating, and you define a facility rating through NERC FAC-008. Does that make sense? Is that?
Yeah, it's very much a two-edged sword, Larry. As Josh said, I think FERC's real mission was finding a way to upgrade transmission capacity without making physical changes to substations and transmission lines. But it also cuts the other way in that it works on the backside of that too, and that most limiting single element is affected by temperature as well. So you'd have to look at it both ways. But I do think their motive was to increase capacity without spending money or spending a lot of money.
Right. Yep. And then one more question that this really kind of deals more with the mechanics of some of this, which is about how many measurements do you think are required for a substation, either to confirm or supplement some existing documentation or to determine, you know, unknowns about documentation, what's missing and what's questionable? Any sense of that?
Brian, you want to take that?
Yeah, that's the question that goes into every proposal that we try to scope out. So that depends really solely on the level of documentation that exists. Some of our clients have purchased systems from other clients, and the lack of records comes along, and they have no idea what's out there, but they're now responsible. We've done it. You know, we have spent 2 to 3 weeks in some substations doing hundreds or even close to 1,000 measurements in a substation, and we've gone out and verified one jumper that could not be verified via the records or visual verification or something like that. I wish I could tell you it's between 70 and 90, but it's between 1 and hundreds each and every time. So
we're oftentimes where we find the most verifications are required on older substations that don't have good as-built documentation. Also for utilities that have grown over the years by purchasing electric co-ops or smaller utilities, they'll have substation documentation from the original owner, the electric co-op, from many years ago, and the large utility now owns that asset and has to make sure it's part of their FAC compliance record keeping. And they at those substations, oftentimes you need a lot of measurements taken to get a complete idea of your facility rating. So that's where I see the most the need for the most measurements in those situations.
Great. Well, we're getting a little bit close to the top of the hour, and I don't have any additional questions that have come in on this, but I thought before we go ahead and wrap it up, I'd pause and loop back to the three of you, see if you have any closing thoughts on this or anything that crossed your mind now that you might not have addressed that you want to just wrap up with.
Just from a business perspective, from a large operational perspective, the client that first asked us for help with this was looking at 5 years to complete it using the old method, and we finished the majority of it in 18 months. So that gives you, it would have been the same amount of measurements either way. That gives you some idea of the speed involved between caliper measurements and terrestrial close range.
That's interesting, and you can see the time savings associated with that. I guess one other area I was going to ask you about is, to what extent is safety a driver associated with use of this technology as well? I'm just curious about what your thoughts are on that.
Well, I think it is. I think it's as much of a driver as the time savings and the cost savings. And the equipment doesn't stick up any higher than anyone standing in the substation, and the ability to measure things from outside the substation, it really does reduce quite a bit of risk.
It's true. I agree.
Josh, Tom, any other closing thoughts before we wrap it up?
No, just want to say thank you, Larry, for this opportunity to present this information. Thank you.
Yeah, I got one thing I do want to say, a couple things actually. Just in response to what Brian said, just to add a little bit to that, I think one of the huge advantages of this approach, it is a much safer approach, but the fact that you don't have to de-energize the substation to do this work, you don't take the transmission lines out of service, so it's done with no impact to your outage schedules and unscheduled outages and that kind of thing. And that's more important now than it used to be, because these lines are in many cases are under a lot of stress and don't have the margins that they had before for a lot of reasons, renewables integration being one of those. So it's a little bit different ball game, and I think it's important to understand that not having to take those facilities out of service to spend a day or two worth of work working in a substation is significant. And then the other thing I was going to say, I just got a note from one of our guys that was sitting in on this. It said they could not figure out how to respond, how to ask questions. So maybe for the next time around, I don't know, maybe that's a problem others are having as well. But I'll
okay. Yeah. So there's a little over on the right hand side. There's a bar or something, and part of it has a questions function, and you can click on that and you can type a question in and submit it, and then we can see it. So that's under the control panel. It's got a question function for anybody who for future reference if anything comes up. But I want to we're getting, like I said, pretty close to the top of the hour on this. I want to thank you, Tom, Brian, and Josh for the presentation on this. we will, the presentation was recorded and we will post it on our website. So folks can either loop back and review it again in case there was something they wanted to focus on and may not have caught the first time around, or others may wind up seeing. And the other piece of it too, actually, there is a question here. Let me whoops, I clicked on the question and it asked about use of a camera. Drew, did you have the question?
Yeah, Larry, it's a question about how the actual number of strands are determined. If you use the camera to determine the diameter of the outside strand, if so, is there a math formula to determine how many strands are in the outside layer?
Oh gosh, that's way above me. So Brian, that sounds like maybe.
Technical question for you, Brian.
Yes. So yes, there is the number of outer strands, the data points that go into it, the outer diameter, the diameter of each individual strand, and then it has to do with the angle at which they are laid. I can't go into anything beyond that because this is patent pending, and this would get really, really mad at me if I did. But I could geek out all day. But yeah, that is those are, you know, three of the things that go into it.
In our calculations also have to take into account whether the strand type is trapezoidal or the traditional round conductor type as well. So there's several data points in there that get pulled into our calculation.
Great. All right. Well, thank you, gentlemen. I really appreciate your time and then the presentation. As I said, it will be posted, so it's going to be available for folks. And I'm assuming that if we do get questions, we can put people in contact with you all to follow up. Assume I'm right on that. But thank you very much. I want to thank everybody who tuned in for today's session. Our next session will be next month in October. It's going to be a presentation by CTC Global on advanced conductors, and we'll be getting information out about that relatively soon. So I think that'll be a good follow-up to this presentation. So thank you very much, everybody, and stay tuned for the next round coming in October. Bye now.
Thanks, Larry.
Thank you, Larry.
All right.